Gate CSE 2021. Consider a 3-bit counter designed using T flip-flops as shown below. Assume the initial state of the counter given by PQR as 000. So if we observe this diagram, the first flip-flop is having the output of P, the second flip-flop output named Q, and the third flip-flop output is R. So these PQR outputs having the initial values of 000. Now the question is, what are the next 3 states? For that, what we do, let us consider the logic diagram given and also the initial value of the 3 outputs. That means P, Q, R. Now, if we apply the first clock pulse, our flip-flop 1, which receives R output as input. So this R output goes input for the P. So R output means its current value R output is 0. That 0 appears as input for the first flip-flop. The moment clock pulse arrives, the P is having initial value of 0 and we applied the clock pulse. Because the T input is 0, it results in no change. According to T flip-flop operation, when the input is 0, it does not change the state. So 0 remains 0. Coming to the second flip-flop, which receives output of the first flip-flop, that too in a complemented form. It takes P bar as T input. The current value of P is 0. Its complemented value means it is 1. 1 is given as input for the second flip-flop, which has the present value of 0. If I apply 1 for a flip-flop, a T flip-flop, it is going to toggle, so it will change to 1. Similarly, if we observe the third flip-flop, which is having the present state value of 0 and takes the input, T input from the second flip-flop, that to Q bar. So Q is 0 means the current value of Q bar is 1. That when 1 is applied as input for the flip-flop, it is going to toggle the state, so it will change to 1. So after applying the clock pulse 1, the flip-flop PQR changes to 0, 1, 1. Now we are going to second clock pulse with the first flip-flop, which is taking R output. So this R output is given as input for the first flip-flop. So here if we observe, the R value is 1. So 1 is given as input for the first flip-flop. And the current state value is 0. Applying 1, it toggles the state, so it changes to 1. Similarly, this 0 present state appears as input to the next one, that too in a complemented form for the second flip-flop, right? In the second flip-flop, present state value is 1 and the present value 0 and its complemented value. P bar means P bar is going to be 1. Applying 1 as T input for the second flip-flop with the present state 1, it is going to toggle, it will change to 0. Similarly, the third flip-flop with the present state value of 1, we are applying Q bar. Q bar means Q is 1, it changes to 0. I mean to say value of Q is 1 means the complemented value is 0. Now we are applying 0 as input for the third flip-flop. When 0 appears, the clock pulse arrives. It is not going to change the state of the T flip-flop, so it remains 1. So after applying the second clock pulse, we have the state as 1, 0, 1. If we verify the results, first clock pulse we received 0, 1, 1. So it matches with option A and option C. And when we check for clock 2, it is having 1, 0, 1. It is also available in option A and option C. We need to apply our third clock pulse as well. Now for third clock pulse, first flip-flop receives R output as input. So 1 we are applying as input. It is going to toggle from the present value, so it changes to 0. Similarly, the second flip-flop which receives output of P bar. P bar means the current value of P is 1 and P bar is 0. That 0, if I apply here as input for the T flip-flop, it is not going to change, so it remains 0. Now for the third flip-flop, it receives Q bar. Because the Q value is 0, its complemented value is 1. When I apply 1 for the third flip-flop, it needs to be toggled. So toggling means, so 1 will change to 0. So after applying the third clock pulse, we have the state of 000. If we compare option A and C, it has the value of 000. So option A is correct. Thank you.